Hello, this is Mr. White, and this is on the trigonometry of acute angles, part 3, solving right triangles. And let me introduce you to what are probably a couple new symbols to you. You should be pretty comfortable with theta by now. That is our Greek letter, which represents either known or unknown angles in pre-calculus and calculus. Likewise, alpha and beta shown here are also Greek letters that represent angles quite often. And you see them here in our first example. This is a pretty standard request in pre-calculus and trigonometry books that you solve a right triangle for unknown parts given a couple pieces of information. So in this case, we're given that alpha is 14 degrees, and you'll see that for the sake of this video, we're going to go back to just using degrees before we go back to radians shortly. And b is 12 inches. Side length b is 12 inches. So those are the two things we know, and the unknowns that we are being asked to find are angle beta as well as side lengths a and c. I should mention that if you feel like this drawing is over-labeled, what about the big A and the big B and the big C, the capital letters? Well, remember, those represent vertices, such that I can label this triangle ABC. Those are the vertices, not the angles themselves. I don't really feel the need for them in this example, so just to reduce the screen clutter, I'm going to remove them here. And suggest that we start in solving those three unknown quantities. Let's start with the easiest one. Let's start with beta. If you recall from geometry, all three angles of a triangle, at least in Euclidean geometry that we stick with, all three angles add up to 180 degrees. And since one of our angles here is a right angle, that's 90 degrees right there, we know that the other two angles, the other two acute angles, must add up to 90 degrees, the other 90 degrees. So I would say that beta equals 90 degrees minus alpha. That's always going to be the case for a right triangle here. And in this case, that's 90 degrees minus 14 degrees. That is 76 degrees. And I hope you agree that that is pretty straightforward, and that if it isn't, as always, that you come to office hours or seek help from somebody who's comfortable with this material. But let me get rid of that calculation and just move it off to the side. Clear myself a little room here, and let's go ahead and tackle one of the side lengths. Now, at this point, you could either choose to solve for little a or little c. It really doesn't matter. I'm going to somewhat arbitrarily choose to solve for little c. And I want you to pay close attention to the process that I go through in determining which trig function to use, because this is where students often get lost. The process is you focus on the angle. In this case, we're given angle alpha. And I'll admit, we pretty quickly deduced what angle beta is, so we could focus on that instead, but I'm going to stick with the one that we are given. So I focus on alpha, and I ask myself, what is the relation of the side that I know and the side that I want to know? That's the question you got to ask yourself. The side that I know, the 12 inches, that is adjacent to alpha, right? And the side that I want to know is the hypotenuse. So with that in mind, you ask yourself which trig function involves adjacent and hypotenuse, and that is how we decide that we are going to use cosine. Pause this, replay it if you need to, but that's the process we go through in determining that we're going to use cosine. So I'll write cosine of alpha, or cosine of 14 degrees in this case, equals the adjacent over the hypotenuse, or in this case, 12 inches, the side that I know, over c, the side that I want to know. Make sense? Okay, so I find that students often get stuck in trying to get c by itself here. There are multiple ways you could get c by itself, but it seems like when the unknown is in the denominator, students often get stuck. Well, the way I'm going to choose is I'm going to multiply both sides by c, and that effectively moves the unknown over to the left side because it cancels out here on the right. And I end up with c times cosine of 14 degrees equals 12 inches, right? Well, from there, I would divide both sides by cosine of 14 degrees, and that would give me c equals 12 inches over cosine of 14 degrees. And notice how I have not touched the calculator yet up to this point. I encourage you to do as much as you can. Basically get to this point And this is the point where you can't really get much further without a calculator. So here's where we'll grab the calculator. But don't type it in too early. Let me just go back to here. I find a lot of students want to go evaluating cosine of 14 degrees here. Please don't. Go as far as I did here, and then grab the calculator. All right. So 12 inches divided by cosine of 14 degrees. We'll do that here. 12 divided by cosine of 14. Go to angle. Don't forget to put the degree sign. And we get 12.37 basically. I'm going to urge you to either leave that on the screen or even better, let's stow that. That's our value for C, right? So I'm going to stow that as C because I want to check my work later, and I anticipate that I might want to use this to check my work. Stay tuned for that. So on paper, I'll write 12.37, or on the board in this case, I'll write 12.37 inches. But I'm going to keep that value with all the extra decimal places in the calculator. So at this point, let me summarize over here on this slide. We were given B and we were given alpha, and we pretty quickly found what beta was, and we just determined what C is. So we've only got to find A now. And there are multiple methods for doing that. I'm not going to go over all of them, but I've just got a little summary of the ones that come to mind for me over here. I'm going to, in just a minute, use the sine of 14 degrees, or the sine of my alpha value. I'm going to use that in just a minute, but I'll point out that I could also look at the other angle, look at the 76-degree angle here, beta, and I could say the side that I know is C. I've just figured out what C is, so I know what that is now. The side that I want to know is A. Those are my hypotenuse and adjacent relative to beta, so I could use, again, the cosine of 76 degrees to solve for A at this point, right? And I'm not going to, but I could have, and I would get the same answer if I do it correctly. Likewise, I'm not going to show you, but I hope you'll pause and consider and make sure this makes sense, that I could also use the tangent at this point of either alpha or beta, and that would allow me to solve for A. Again, please pause and make sure you agree with that statement. I could use the reciprocal functions. I could have done that from the beginning, the cosecant, secant, cotangent. I could have made use of those, although I'll admit for this type of problem, I don't see any reason to go out of your way to do so. Finally, I could use the Pythagorean theorem, because I know what C is and B is at this point, so I could use the Pythagorean theorem to find out what A is. I would suggest that you get in the habit of using one method, picking one method, but then using another method to check. So I'm going to use this method, but then I'm going to check with this method. And I strongly, strongly urge you to get in that habit. I hope to show you that it doesn't take you very long to check, yet it can save you a lot of heartache by catching some silly mistakes. So let's solve using the sine of 14 degrees. That's because alpha is the 14 degrees that we were given. And again, relative to that alpha, I know that C is 12.37 now. And even better, I've got it stored in my calculator, 12.37 inches. And the side that I want to know is A. And those are my hypotenuse and my opposite, respectively. So that tells me that I will use the sine function. Sine of 14 degrees is what equals opposite A over hypotenuse C, which is 12.37 approximately. I should use that little squiggly equal sign because that 12.37 is not exact. And from there, if I get A by itself, that would give me that A is approximately equal to 12.37 inches times sine of 14 degrees. And here, again, is where I urge you, even though I'm writing 12.37 on the paper, come back to your calculator and either use that stowed value, or if it's the last thing that appears on your screen, just do times sine of 14 degrees. Don't have to close that parentheses. I don't like to encourage laziness, but I'll admit I don't have to close it. And that gives me 2.992 basically. That is my new A value. And again, I could stow that. I could stow that as A if I feel the need. Doesn't take me very long. That is my A value, 2.992. So I'll put approximately equal to 2.992 inches. I could put it over here just to say, yes, I am done with this problem, except for the checking. So again, I really shouldn't consider myself done until I've checked, and here's how I'm going to do it. I know that these three values, these three side lengths, are part of a right triangle, so they should honor the Pythagorean theorem, right? So here's what I'm going to do. Since I've already stowed those values, I'm going to say that since a squared plus b squared should equal c squared, I'm going to type in alpha a, which I've stowed, and b squared, b is 12. I didn't stow that. I'll just type in the 12 squared, and I get that, 152.95. And I ask myself, check, is that equal to c squared? Well, let's find out. C squared, it is equal to c squared. Look how quick that was. And imagine how many headaches that could save you when you find out that you made a mistake, and it's probably a silly error, and on a test you can use that to check your answer. Okay, for time's sake, I don't want to keep this video going any longer than it has to, so I'm going to skip this example, but I would say again, if you are having trouble determining which trig function to use, please quickly come get help on that. That's a major skill you need to know. Okay, two more quick examples. I have a worked out problem here that represents a common error that I see students make. Now, I would say I sure would love it if you pause the video and see if you can find the error, but that's not really the point of me putting this slide up here. So at this point, I'll mention that the error occurs going from this step, which is correct, going to the next step. It's not correct. If we correctly isolated the variable c, we should get that c is 20 centimeters divided by cosine of 70 degrees. And that's a mistake I see students making often, and I'm sure I'm going to see it this year. So what do? Is there a way that you can detect that you made that mistake? I would argue yes, and it's fairly simple. You basically just look at your results and you ask, does this make sense? Here's what I mean. We just solved, or this fictional student just said that c is 6.84. So if I look at that on my original diagram, 6.84 centimeters, and I look at the original given information of 20 centimeters, it becomes immediately apparent that something is wrong because there's no way that the hypotenuse should be less than this side length, right? I hope you agree with me that didn't take long to just do that quick check. And again, you can catch a lot of silly mistakes just by doing that sanity check. Final example, similarly, I've put a problem here, a process that contains an error. And again, if you want to pause the video and find the error, that's excellent. But I'll go ahead and tell you at this point that the error occurred in typing in the trig equation. Again, it's very common to make the mistake, typing in sine of 21 radians instead of sine of 21 degrees. And if you're wondering, how do I detect that error? How do I make sure that doesn't lead me to a wrong answer on a test? Well, again, I'd say just stop and do a quick check at the end. I'm going to say that this picture that we have here is not the best picture. If beta is 21 degrees, that's what I would say is a relatively small angle, especially compared to this picture here. So let me get rid of that picture and try to draw something a little bit more reasonable. Okay, so let's say there's my right triangle, and I think that's a little more reasonable version of 21 degrees, and that is our beta. And that means that alpha over here is going to be 69 degrees. And again, if I just do a quick sanity check for my results here, little a down here was calculated to be 4.382 meters using that incorrect calculation of sine of 21. It was radians instead of degrees. But that little a is across from alpha, so that means it's over here. And little b here is right here, 6.693. And again, if you just look at the picture that you drew, which hopefully is a reasonable picture, I hope you agree it's pretty apparent that there's something wrong here, because you remember from geometry that the smallest angle is supposed to be across from the smallest side, but 6.693 is not the smallest side. Likewise, this 69 degree angle, I'd say that's the middle angle. It's between 21 and 90 degrees. It's supposed to be across from the middle length side, and it's not here. it's across from the smallest side. So there's our indicator. I ask that you not just passively get an answer, but you actively check, does this make sense? Okay, let me get you on to the, quick list of the things to check for. Again, make sure that the hypotenuse is the longest side. Make sure that the small side is across from the small angle, etc. I didn't demonstrate this one, but hopefully you recall that when you add the two shorter sides of a triangle, that they should be greater than the longest side. That might catch you some silly errors. And finally, verifying with another method. So again, if you solve all your sides using trigonometry, use the Pythagorean theorem to check. Okay, now let me get you on to the exercise. You try. Pause the video, please. All right, let me reveal the answers. Okay, and this does pass all our sanity checks. In each case, the hypotenuse, little c, is the longest side. In both cases, the shortest side is across from the smallest angle. So in both cases, the shortest side is little a, right? And in both cases, the smallest angle is alpha. And finally, the sum of the two shorter sides is greater than the longest side. A and B add up to a value larger than C, the hypotenuse in both cases. So it passes our sanity check.